Here we're going to look at a bunch of examples on how to solve a quadratic equation by the ideas of factoring. So first and foremost, the biggest thing that we have to do when looking at any equation is you need to make sure that it goes into standard form. As a reminder, when we're talking about standard form, we are talking about ax squared plus bx plus c equals 0. Okay, in other words, setting our equation equal to 0. So here if you look, I have a 15x equals 3x squared. So I'm going to take this 15x and move it. So I have 0 is equal to 3x squared minus a 15x. Now, once you do that, and you get it set equal to 0, the very first thing you always want to do is look and see if you have a GCF. So here I have a 3x squared and a 15x. Just looking at this combination, I automatically know that I can pull out a 3 and I can pull out an x. When I do that, I have 3x on the outside, and then I look at what's left over on the inside, and in this case, this would become x minus 5. Now, because we've factored by greatest common factor, the next thing you have to do is you have to set each factor equal to 0. Now, here's the important thing to remember, is that yes, 3x is a factor. So here, and the reason for that is because of the x term. And so what we do is we were going to have that 3x is equal to 0, and we're going to have that x minus 5 is equal to 0, and we have to solve both. For this first one, divide by 3, and we get that x equals 0. On the second one, add 5, and we get that x equals 5. And that's all there is to it. So here, when we're talking about your solutions, we have that x is going to equal 0 and 5. Now, if we look at this next one, notice I have to do a little bit of work before I can actually do any solving. So the first thing that I need to do here is I need to distribute my x term through. And then on the other side, I need to distribute my 6 through. So here, this is going to become 2x squared plus an x. And then we have a 6x plus a 12. Now we can go ahead and start moving things from one side to the other. So my x squared is positive. I want to keep it that way. So I'm going to take everything on this right hand side and move it over to the others. So my 2x is going to, or my 2x squared stays the same. X minus 6x becomes negative 5x, and then minus 12 equals 0. Now that we have that, notice we have a trinomial. In this case, my trinomial is greater than 1. And so here, one of the things that we can do to solve is you can use either the reverse FOIL method, and I can show you how that works. Here, because my coefficient is greater than 1, what I have to remember is this first term has to break. The only way a 2 can break is into 2x and x, so factors of 2 are 2 and 1. I have to look at my signs, so there's a few things I need to remember about my signs, and that is that this back sign tells the possible options to use. In this case, the option I'm looking at is positive times negative gives me negative. And then the other thing that I have to keep in mind is what my front sign tells me is that because my back sign is negative, my front sign, this tells which factor must be negative. So here, because this middle term is negative, it means the bigger factor is negative. And so here, if we're looking, I have to figure out which one of these factors it's going to be. Now the last thing I have to look at is I have my 12. So I need factors of 12. So that's 1 and 12, that's 2 and 6, and 3 and 4. And I need to know which factor of these, when combined, is going to give me 5 as a result. So here, if I look, I have this 4 and this 3 here. If I put a 4 on my right hand side and a 3 on the left, notice if I FOIL, 2 times 4 gives me 8, and then 3 times 1 gives me 3, and what do I know? I know 8 minus 3 gives me 5. Since I want my 5 to be negative, what that tells me is that my 3 has to be positive and the 4 has to be negative. So take a look at it. 2x times a negative 4 is negative 8, plus 3 gives me negative 5. Okay? So now that I have my factors, I have to go ahead and solve. So I'm going to take each factor and I'm going to set them equal to 0. So here I'm going to have 2x plus 3 equals 0, and I'm going to have x minus 4 equals 0. For my first one, I'm going to subtract 3 and divide by 2, so this is negative 3 halves. For my second factor, I'm going to add 4, so I have x equals 4. Alright, so this next one, I'm going to take this stuff on the left hand side and I'm going to move it over because my square is positive. So 0 is going to be 4x squared minus a 17x minus 15. In this case, again, I can solve, and here I'm going to show you that bottoms up method. So this says I'm going to take a times c, so this is 4 times negative 15. That's going to give me a negative 60. Again, in looking at my signs, notice I have the same combination as I had above. So here my back sign tells me I'm using one positive, one negative. My middle sign tells me the bigger factor is negative. I need factors of 60 that when added together give me 17. So 3 and 20 are going to be your best bet. Since the bigger factor is negative, we'll have positive 3, negative 20. Of course, here you could list all your factors of 60 if you don't know them right off the bat. Now with this, we have to go ahead and set up our factor. And so here we're going to set it up by saying x. The first one is going to be plus, and I have 3 over 4, so it's your factor over your a term. And then here this is going to be x minus, and you're going to have 20 over 4, so factor over the a term. And this is still set equal to 0. Now we have to look at each of these factors, and we have to reduce them as far as they can. This first one is already reduced, so this is still x plus my 3/4. And my second one, 20 over 4 reduces down to x minus 5, still equals 0. Now in this case, I don't have to finish the bottoms up idea because we're trying to solve. So here you would have x plus my 3/4 is equal to 0, and x minus my 5 equals 0. And the first one, I'm going to subtract 3/4 from both sides, so x is equal to negative 3/4. And x is equal to 5. Alright, so the last two that I'm going to look at are these right here. So with this first one, again, I have to move my 48. So here I'm going to have 18n squared minus 48n plus 30 equals 0. Now with this, I want to look for a greatest common factor. Notice I only have variables in 2 of my terms, so my greatest common factor is going to come from just the numbers. To do that, I'm going to start with 18, and I'm looking at its prime factorization. So here this is 9 and 2 my 9 is going to break down into 3 and 3. I then have my 48. So 48 again becomes 2 and 24, which is going to become 3 and 8. And then I have my 30. And 30 is going to break into 3 times 10. My 10 breaks into 2 and 5. Now notice I didn't finish breaking my 8, but I don't have to. If you take a look, I only have the 2 and the 3 in common with all of my terms. So breaking the 8 all the way down is not going to help me any, so I can just go ahead and leave it as is. So what this means is that my greatest common factor is going to be 2 times 3, which is 6. What it also means is that in each of these I have some numbers left over. So under my 18, I still have a 3 left over. Under my 48, I've got the 8 left over, and under 30, I have the 5 left over. So I can rewrite this equation, or this equation here, in terms of new terms. I'm going to pull the 6 out. It's going to leave me with 3n squared minus an 8n plus 5. Now I'm going to work on factoring this trinomial here. So in this case, I would have that my AC is going to be 3 times 5, which is 15. I need factors of 15 that give me 8, so I have 3 and 5. Since my back term is positive, what that means is that I have 2 options to choose from. So again, this back term here tells you the options. So in this case, I have positive times positive equals positive, or negative times negative equals positive. What that also then means too is that, let's see, I'll write it this way. This middle term here is going to tell you the option to choose. So here I need to add to a negative, so that means I have to make my factors be the negative factor. So that means that these are both negative. So to set up my factors, I still have the 6 out in front, and this is going to be x minus 3 over 3. Sorry, not x, n. This is n. And then we're going to have n minus 5 over 3. This is still set equal to 0. Bring down the 6 yet again. Reduce, so this is really n minus 1 times n minus 5/3 equals 0. Now, this part here, this 6 right here, we can divide out. And the reason we can divide that out is purely because we're set equal to 0. So we can divide the 6 away. It's going to leave us with just the n minus 1 times n minus 5/3. So here, my n minus 1 equals 0, n minus 5/3 equals 0. So I have that n equals 1, and I have that n equals 5/3. And those would be my solutions. Alright, so the last one I want to look at is this one here real quick. So in this case, for this, we have to FOIL because we have to get it into its x squared forms. So here this is going to be x times x is x squared. X times negative 1 gives you negative x plus a 4x minus 4 equals 6. In this case, I have that x squared plus a 3x minus 4 equals 6. Move the 6 over. X squared plus a 3x minus 10 equals 0. In this case, I hold a coefficient of 1, so I can now reduce or reverse that FOIL. X squared breaks into x and x. My back term is negative, so I have one positive, one negative. My middle term is 3. I need to look at factors of 10. So when I look at 10, I have 1 and 10. I have 2 and 5. So I want to know which combination is going to give me 3, and I want it positive. So the 5 is positive, and the 2 is negative. Again, we're set equal to 0, and so here we would have that x plus 5 equals 0, and x minus 2 equals 0. So in this case, x equals negative 5, x equals 2. So in a nutshell, that's kind of everything you need to know in order to get started with the idea of solving quadratics by factoring. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video, and I'll see you next time.